Hi guys, and welcome back to the channel. So today I'm going to be showing you how to debug if your camera is bad with the oscilloscope here. So I'm going to show you how to test if your camera is still functioning correctly, and if the problem could be through the OSD. I'll also show you how to test in the OSD here and help you understand what each pin is, not in super depth, but if you guys really do like this content, we could really go in and dissect OSD chips, the regulators, the microcontroller units on them, the USB power, all that kind of crazy good stuff. I know I've promised this a long time ago, and many of you have been actually requesting this quite a lot, so I thought this would be the perfect time to do it. So for today's test, what we're going to be testing is we're going to test cameras. I'm going to show you how the signal should look like, and what to look for, and as well as show you how to use this oscilloscope. Now, this is like a $70-$80 oscilloscope, which is really nice. It really does work absolutely phenomenal. You can get it from Banggood, but this is an overall very good device to get you going, to just introduce you to some electronics, so you can see little signals. You can see if the signal is going through or not, and we'll get into that later on. Right now, let's just do something very basic. So this thing comes with everything you really need. I highly recommend, though, you purchase a screen protector and a cover for it. I'll leave those linked down below. I wish I had, because mine got a couple cuts, because they don't use Gorilla Glass like on our smartphones. It's just a pretty decent glass that is really easily scratched. So just get it a screen protector if you're planning on you putting it with your tools. So we're going to be using this. I don't know if we're going to be using the continuity. I won't show you how to trace everything, but maybe that's for a more advanced topic. Right now, I'm just going to show you the OSD, if it's functioning or if it's not functioning, and as well if the camera is functioning or not, or it could be through your VTX. So let's get started. Now, some of these are CMOS, some of these are CCD, and some of these are like black and white CMOS. What is this? This is the Night Eagle 2 Pro. This is the regular, what is this? This is like the Hakcrc clone. This is a CCD camera. And this is also a Hakcrc HS1177. This is the newer version with kind of like a metalish body, which is really nice. It's also a CCD 600 TVL line, as I believe, and this one's also a 600 TVL line. This is a 1200 TVL line CMOS rolling shutter camera, which is hella quick. It's called the Cadex F1. They're gonna stop production of this because it's a micro camera. They're about to stop production because they're going to release newer one with a microphone on board. Now, I don't know if that'll affect the latency, but this is by far one of the fastest cameras in terms of latency I have ever tested. So it's overall, it's a really, really nice camera. Very good light transition. The quality is superb. Obviously, there's going to be always better quality, but the quality is, better than what is taken by the mainstream, which is, I believe, the Hakcrc HS1177 type cameras, and as well as the Runcam Swift 1 and 2. So this one is a really nice overall micro camera. I'd highly recommend. Plus, it's $20, which is awesome. That's how much a camera should be, in my opinion. All right, so I'm going to show you how to test cameras, and also we're going to go ahead and check out the OSD, how it works here. I do have a microscope, the HD microscope, which will go in and you guys can see in detail which pin is what, and all these kind of crazy cool things. So enough talking, let's get started. So first things first, let's just test any camera. We're gonna test let's just test here the Hakcrc, or the just the basic Runcam type camera. They all look like the same signal, and you'll kind of get an idea of how a video signal should be. However, this thing doesn't have a trigger for a video signal, but I'll show you what to look for, and it's actually pretty simple. So first things first, we're gonna have to boot this guy. And just give him a second. It boots very quick, actually. And we are greeted with this screen. So let's go ahead and actually zoom in here, and so you guys could see what I'm doing. So we do have a couple buttons here, and we need to prepare the oscilloscope, because every time it boots, it just has this really its own default settings here. So first thing we want to do is we're going to keep channel A to 1 volt here. And as you can tell, I have my oscilloscope probe connected to channel A, which means this is A. Now channel 2 is off. You don't see a yellow line here, which is nice. See, forget it. Now the time base is very important. We want to drop it down to, let's just say 0.1 microsecond. We'll play with that in a little bit. Now the trigger is very important here. The trigger is yellow. Yellow is channel 2, as you can tell right there. This is not a touch screen. So you need it to be on A, sorry. So we need the trigger to be blue, like this. Now it's going to be this line, this dotted line here is going to be the trigger. Don't worry if you're getting confused. It's very simple. You'll get the idea in a little bit. So what we want to do is we want to click the mode in when you're on trigger, and we're going to keep it auto, and just give me a moment. So I've switched it again. Okay, so we want the trigger to be blue. Okay, and trigger mode up, channel A, perfect, threshold, That's fine. Auto fit, it doesn't matter, but you could just keep it on. So make sure your settings look like this, and I'll explain what these mean. Especially the threshold is very important, because if I move it, let's just show you here. You see that line that's moving? That's the trigger point. So you'll see what I mean in a little bit. All right, so everything is set up right now. It's triggering on blue, which is channel A. So let's go ahead and connect the camera. So let's see how we're gonna do this. So let's just move this back a little. We're gonna bring in a camera, and what you're gonna have to do is basically desolder your yellow wire, which is the signal wire. And if we bring this here, this is how I'm applying 5 volts to my camera. So here's the 5 volt, this is ground, and this is the signal, the yellow line, the video line. And as you can tell here, I've kind of cut up the ground here because we also need a ground. We need 2 wires to check any signal, which is the ground. Always you need ground, and the signal that you're looking at. As you can tell, red, we don't have anything to do with the 5 volt here. So what I'm gonna go ahead and do is apply power. So we're gonna go ahead and apply power. So basically it's like it's connected on a flight controller. And I'm gonna go ahead and connect this guy. Okay, so now my camera is connected. So you won't know it's booted because obviously there's no LED notifications and all that kind of crazy things. So in reality, you probably have your flight controller here, and you're gonna need ground, and this one you're gonna have to desolder. So let's start simple here. So what you would want to do is you're gonna go ahead and grab your probe, as you can tell right here, and this side here is going to go always on the signal that you want to look at, and you can see this, it looks very nasty. It's because we don't have ground. And on the flight controller, you're going to need to find a ground pad and just put it on the ground there. However, here I have it pre-set up just to set up the ground just like this. There we go. So now I have ground, and now it's working. Now you're like, okay, what the hell's going on? How do I know if it's good or not? So just be a little bit patient. We'll see right now. All right, let's just bring it back. Okay. So now we're on this screen. So what we want to do is we actually want to decrease the time a little bit. So, and then let's go to the trigger here, and we're going to play with the threshold. Now your threshold may vary. See, your threshold, your thing might be going like just crazy here. So set it up to 20 milliseconds, which is pretty good because it's roughly within every half a frame. So this is a perfect working signal. These here are called the I forgot what they're actually called, the equalization pulses, if I remember correctly. This basically means it's a start of a half a frame, and this is another start of a half a frame. So 2 of these is a full frame. So that means that it's working. And how do you know? Check this out. If you do crazy things to it, now it's fully black. This is basically full black right there. So now we know the camera is working. This means the camera is absolutely functioning perfectly. And if it's not, it would probably be just a flush line somewhere, or doing some weird things. But now this has a video feed 100%, because this is how a video signal looks like. Make sure you take note of the settings. Later on you can understand them by yourself if you play around with them. So I have the time base set to 20 nanoseconds, or these microseconds. 20 microseconds. Yeah, 20 microseconds. And the trigger is just right above this little line. You could always play with the trigger. So if we go here and we go to the threshold, where is it? Right there. As you can tell, it's on 24. And if I move that line, which is the trigger, now it really doesn't make sense. And especially if I just go completely off of the signal, this is what you'll see. So you want to put it in to kind of get an idea that it's working. Just move it around until you get it just right. And then later on you could do your little research, and we can get in a little bit more advanced video. So we're right here on the beginning of the frames, as you can tell, those little pulses down there. So this means that this camera is working perfect. All of them look the same, just to show you that all of them do look the same. However, the threshold might change from camera to camera depending on the signal. So let's just show you here. Now I'm connecting the Eagle, what is this? Night Eagle Pro 2, I think, yeah. So I'm gonna go ahead and connect this one. All right, so this one is a black and white camera. This is for night mode. As you can tell, it kind of looks different. It's because right now it's broadcasting in black and white because this is a night camera here. And if we go to the trigger, and as you can tell, it's not really stable. So we're gonna go ahead and drop the trigger here, which is that dotted line, as you can tell. And now we've stabilized the signal here. Now it looks pretty proper. So now we can go ahead and put our finger in front of it, remove it, and do all kinds of crazy things to it. Here we go, put it to the light up there, and then here's another light over there. And it's really nice. So that's exactly how I look right there, if you could read that. So yeah. And if you guys want just unsure, let's go ahead and grab the micro camera, which is the CMOS rolling shutter camera, which is the CADX here. And again, you see the signal is messed up. You just have to play with the threshold there. So we're going to go to trigger again, and we're going to go to the threshold, and we're going to just move that dotted line towards the signal until it equalizes really nicely. So there we go. It's really nice. And the camera's perfect. It's running perfect. Actually, I couldn't find any broken cameras. I wish I did have one, but this means that it's outputting a signal of actual real video signal 100%. There's no way it'll be outputting something like this and you won't be getting a video signal, because this is a perfect video signal. So that's really nice to see. So that's in terms of camera. It's really simple. You just got to know how it looks like, and that's how it looks like. Just make sure you set it to 20 microseconds here, the time base, and the trigger to be on blue. Just take a look how this one's set up, and you can go ahead and do that. You can play with the voltage. It'll make the lines bigger and smaller. Well, again, we'll get into that later on. So that's how you would test the camera here. Now we know our camera is working 100% sure. So next step, we want to test the OSD. Now, lately we have black screens, or just, something is not right with the OSD here. So there's many ways to test the OSD, and in this video it's just going to be very simple because it's a little introduction. What we're going to do is we're going to go ahead and find the output pin, and as well as just go to the output of the flight controller. Now let's start easy, and we're going to get into the microscope and show you which pin on the OSD is the output if you ever wanted to trace it. And it's usually connected to a resistor. I think it's 75 ohm or 75k ohm resistor, I forgot, and some kind of capacitor. If you could trace those back down to the pin between the pad and the pin and see maybe the resistor is broken or the cap is broken, you could always do that. And we'll get into that again in a separate video where we do a dedicated video for just the OSD chip. So now what we want to do is I really want to test if the OSD is working. Now obviously it might be in your quadcopter, so some flight controllers, the OSD will boot just through USB. For this one, I'm lucky it does boot through the USB, but even if with your quadcopter, make sure you remove your propellers, stick in the battery, and I'll show you what to do. So let's pretend that we went ahead and did that. So let me just unplug this here. Alright, so I'm gonna go ahead and give this power through the USB. Alright, so I've gone ahead and prepared the USB. Now I'm just going to give it power, and we should be good to go. So it booted. I know for sure the OSD boots on here. So now what do we need to do? How can we test this? It's actually very simple. We need to go to the video output, not the input, the output, because the output is going to be currently outputting OSD even if there is no input video. So the V out is that one right there for me. It could be V out or called VTX or VO. You know your quad, your flight controller, so you would know the place where your VTX connects to the video signal. So the OSD chip is back here. We're gonna come back to that in a little bit. So right now, what do we need to do? Well, first you need to grab your probe, and this does come with the oscilloscope here. So let me just zoom out. What you can do is you might like, okay, well, how am I going to touch it? I might bridge something. Don't worry. Just push this out and you have a little probe here, which is really nice. So that's what we're going to do here. And then we're going to pick up the flight controller from the floor because it fell. And there we go. So first things first, what do we need? Well, we need ground. That's very important right now. So where's ground on here? You could take any ground. I'm going to take this big pad right here of ground. So make sure you don't touch anything though. So just make sure here I didn't touch anything. Especially if you have your battery, make sure you put this somewhere nice, or just solder a small ground wire that's going out somewhere so you don't risk ruining it just because you wanted to test the OSD here. Alright, so let's go ahead and see. Where's V out? V out is right there, so it's this top one right here. So what happens if I put my probe right there? Can you see? Does it look similar? It looks very similar there. They all look exactly the same. That's how they work. You got your little half a frame pulses there. And I forgot what they were called. I truly did study the signal completely, but I just haven't seen it in a while. But yeah, that's perfect. Each one of those dips is starting of a half a frame. So NTSC or PAL, they're both the same. Just their size is different. Just a little bit different. I do have a video that goes really in depth with my big oscilloscope if you're curious. Or I might just redo another one if you guys want to see an updated version of that stuff. So currently the OSD chip is working. It is broadcasting OSD. Obviously, if it wasn't, you would not see anything like this. I tried to look for an OSD chip that wasn't working, but I really couldn't find one. Maybe I'll burn this one or something so I could show you. But overall, currently, it's working perfect. So it's outputting, the OSD is outputting something. So that's really great to see. So now let's go ahead and find the output, the OSD output on this guy, on the chip. So the chip is this little guy right here, and they all look alike. So it's this chip right here. And let me go ahead and prepare the microscope, and let's go in and check this out. So give me a moment, guys. I'll be right back. Alright guys, so I've gone ahead and I've prepared the microscope here. It's absolutely awesome. I got this from Banggood if you guys are curious. So let's go ahead and check this out. Now I don't know if the current latency, how bad it is, so you know if it's going to be in sync. So this is the OSD chip, and they're all like just exactly the same basically on every single one. And you can see this little dot right there, and that little dot just means that this is the where you would start counting the pins if you're looking at the data sheet. Now let's go ahead and take a look at this. Now we have pin 26 is the video output, and pin 26 would be all the way up here. It would be this third one right there, and this one would usually be connected to a capacitor and then a 75 ohm resistor to the output, but it depends. The capacitor is not really, you don't really know what it is, but currently the video out is right here. This is the resistor that's connected straight to the video out, because that is the video out pin right there. And it's going through this cap right there, probably through some other things. I did trace it out. So, you know, if you ever trace out your, let's just say your video out pad, find the resistor, test it, because usually it would be a 75 ohm resistor. And if it's reading 0 or something, then it could be the problem from there. That's if the pad's not working, so if you're not getting signal on the pad. So the next step would be to do the same exact thing we did the oscilloscope on the pad, but on the pin, which would be pin number 3 right there. Which is, if you take a look at the little, it's not pin number 3 actually, it's pin number 26, but starting from here that would be 1, and this is like 1 through 14, pins 1 through 14, and then it goes up here 15 through 28. So it would be just, if you just find the little dot, go up, count 1 2 3, so it's that third one right there. That's the video out. So this is where you would want to touch the oscilloscope. It was very difficult to show you this with the bigger camera, and that's why I went ahead and set up the microscope here. So this is the part where you would want to test, and you could actually test and see the signal through these guys as well, which is pretty nice to see. We do also have some other things. For example, if you wanted to make sure that the OSD chip is receiving its 5 volts, which one would you actually check? Well, you would have to check pin number 3, the official pin number 3. So you'd find the dot and you would go 1 2 3. So this one, and touch it with ground with your multimeter. Make sure it's getting 5 volts. If it's not, then something is wrong with the power and not the OSD chip. The OSD chip might still be fine, and it's the 5 volt regulator that's not providing the power. So that's another thing. And also you do have your little clock here, which goes to pin number 5. And again, I don't want to go too far deep in this, but we'll do that in a separate video. I want to see you guys' reaction. If you guys are really interested in this, we can go really deep into this, and also even check out the video input on this guy. And if you're curious which one's the video input, since we're here, the video in is pin number 22. So pin number 22, we would have to go up here, and then we would have to count 15 16 17 18 19 20 21 22. So it's that guy right there, as I believe. Maybe I counted wrong, but it's pin number 22, which is around the middle area. Yeah, it would be the most middle pin, because each of them are 7, kind of 14, and it's pin number 7 basically. So yeah, I don't want to lose you. So yeah, it's pin 22 that is video in, counting from here, which would be starting at 15. This would be 15 here. So count till you go to 22. And I think that's it, guys. So let me go back to the oscilloscope. Let's go ahead and take a look at it, and then we'll continue from there, guys. Alright guys, so that's how you check for the OSD if it has an issue. Like I said, check the pad, the output pad on the flight controller, and after that, if it's still not receiving any signal, you need to check pin number 3 that was up there. It's going to be very difficult to show you again, but it's the third one from the top. Like if you see the little dot, the third one, check that one with the oscilloscope. Just be careful when you're coming in to touch it, so you don't bridge anything and burn the OSD if it didn't have an issue. So if you were to see signal on the OSD on that pin right here, then it's going to be something with the route to the output there. So it would probably be a resistor or a capacitor and that nature. And pin number 3 on the bottom here with the little dot, if you count the third pin from there, that's the 5 volt. So you would have to actually take your multimeter and just check the voltage. Go to pin number 3 with your positive lead, and with the black one, go to ground and see if it's receiving 5 volt. If it's not, then it's not receiving power. Thus means possibly your OSD chip is still fine. It's just an issue with the 5-volt regulator on board. So that's, or just the route to your OSD chip, depending on the hardware. And like I said, we can get into this into more detail and get a couple more flight controllers here to test out later on. We could actually see, also check out the F4 processors, and maybe even do repair videos. I really want to do some repair videos as well. I think that'll be pretty interesting and pretty cool. And yeah, that's it, guys. So I really hope you guys do enjoy this content. I really hope it's somewhat useful to someone. I did promise you I'm going to be doing a lot of debugging video. I will be doing a lot with this little tiny oscilloscope, and it's just an overall little beast of a little oscilloscope here. It's chargeable, portable, but I highly recommend you at least get the screen protector for it. I'll leave those things linked down below. It's a really nice, it's a really nice piece of hardware, and it's upgradable. You can do all kinds of crazy stuff. It can be even used as a signal generator, and we can get into that stuff in a different topic once we do a little bit more advanced things. But overall, you get everything that you need with it. So you got this little guy and you got this guy. So make sure you put the tip here before you start using it, or you won't get any signal, because these come out and you just need to push one in. So yeah, so overall, that's how you would check, just a basic way to check if your camera's working or not. I know there's many other ways, but here's a really scientific, nice way, which kind of introduces you into electronics and kind of opens up that door just step by step. And later on, I could help you understand what a signal really is. All a signal is a voltage fluctuation in a specific amount of time. So basically, in theory, one would be the voltage would go up from 0 to 5 volts for 2 microseconds. That would be interpreted as a 1. And if it was going up for 4 seconds, that would be a 4 microseconds, and that would be like a 4 or something. But yeah, we can get into that later on. So yeah, again, I really hope you guys enjoyed the video. If you guys want to see more of this stuff, please let me know down in the comment section. And I'll leave a link to everything down below. If you could use those links, those greatly support the channel. Or you could just support me on Patreon. That'd be super awesome. I need all the support I can possibly get. And yeah, it was really fun. And I really hope you guys enjoyed it. Now we'll see you next time. See you guys. Take care.